Put your brain in the game.
To swing or not to swing? That is the question. Of course, Troy doesn't have that much time to make up his mind. These pitches come in fast. Really fast. Hitting a baseball is one of the hardest things to do in all of sports. It's hard. Ooh, it's really hard. Ugh. It may be impossible. These days, Major League pitchers consistently throw the ball over 90 miles per hour. Troy has to pick up the pitch, decide if it's a strike or a ball, and whether or not to swing. And you have to think fast. But how fast? To help us figure out how much time, we've got Troy Gloss. He plays third base for the Anaheim Angels. He batted .287 and 47 home runs last year, and he was a member of the 2000 All-Stars. So I'd say he thinks pretty fast. Okay, Troy, think fast. Oh, wow. You were really quick. That's .13 seconds. But you gotta be fast to hit a baseball.
Yeah, you gotta be very quick.
Do you have any idea how long you have to decide whether or not to swing?
I have no idea, but it can't be much.
Well, you know what? That's what we're gonna figure out today. Exactly.
Carl Ravage here at Baseball Tonight. Have you ever wondered what a 95-mile-per-hour fastball looks like to a batter? Didn't take long, did it? Here's so much time you'd have to swing. That is fast. Statistically, hitting a baseball is one of the hardest things to do in all of sports. If you're hitting .333, you're one of the best batters in the league. But .333 means you're only hitting the ball 1/3 of the time. Outstanding basketball players hit 60% of their shots. Good quarterbacks connect on 50% of their passes. But in baseball, hitting .250 is pretty good. And that's just 1 out of 4.
Okay, guys, how much time does Troy have to decide whether or not to swing? And how can we figure it out?
You can use some kind of laser timing thing.
Interesting idea, but perhaps a little complicated, expensive, and you would need a laser. How can we do it with just a tape measure and some math?
If you know how fast the ball is going and what the distance is, you can figure out the time.
Right, Stephanie. Speed, distance, and time. Speed, distance, and time. They all go together. Like if I'm going 60 miles an hour and I need to go 60 miles, I'll get there in an hour. It's simple, right? To figure out how long it takes the ball to reach the plate, we need to look at speed and distance, and from that we'll get the time. All we need is a simple equation that looks like this. Speed times time equals distance. How fast times how long equals how far. Okay, guys, so we need numbers for speed, time, and distance to fill in our equation. Which one's the easiest one to get?
Distance, because all we have to do is measure.
Right. So go to it. Hustle, hustle, hustle. Okay, guys, so what do we get?
60 feet, 6 inches.
Okay, so that's the total distance from the tip of the rubber all the way down to home plate. But what do we have to take into consideration if we want to be really, really exact?
Well, we have to remember that the pitcher doesn't release the ball right from that mound.
Yeah, they step out and extend their arm.
Right, he releases the ball somewhere out here. So what we have to do is figure out what this distance is and then subtract that. Okay, let's bring in our pitcher. Okay, guys, go to it.
8 feet.
Wow, that is a lot closer to the plate. So we got 60 feet, 6 inches minus 8 feet. So that gives us 52 feet, 6 inches. That's our distance, 52.5. So Troy, the pitcher really takes a big bite out of that distance with his reach forward.
Yeah, that's why he has to keep 1 foot on the rubber, because every foot he steps forward, the ball's getting there that much faster.
Okay, so what's the next number we need for our equation?
Speed of the ball.
How fast does Randy Johnson throw at you?
Randy throws about 95 miles an hour.
Okay, so that's our speed. So now we know how fast the ball is going. We have our speed, 95 miles per hour. So it's a really simple problem, just solving for one variable. Okay, so how do we figure out time?
You just divide both sides of the equation by the speed, 95 miles per hour.
Okay, that sounds doable.
Wait. There's a problem.
What?
Our measurements have different units.
Huh?
Yeah, Speed is in miles per hour, and distance is in feet, so the units have to agree.
Yeah, they have to, because it's like comparing apples and oranges. They're different.
Okay, that's a good point. So how do we do that?
We could convert miles per hour to feet per second,
Well, why not feet per hour?
because it would be some ridiculous huge number. Yeah, parts per hour instead of parts per second.
Okay, so let's convert 95 miles per hour to feet per second. How do we do that? First, you have to multiply miles per hour by the number of feet in a mile. Oh, how many feet are in a mile? Can you tell me how many feet are in a mile?
No.
5,182.
You are so close.
5,280.
Right! Ding, 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 ding! He got it. Okay, so 95 miles per hour times 5,280. Now, we just divide by the number of seconds in an hour. 60 seconds in a minute, 60 minutes in an hour, 60 times 60 is 3,600. So 95 miles per hour times 5,280 is 501,600. Divide that by 3,600 and we get approximately 139 feet per second. Simple. Okay, so now we know that a 95 mile per hour fastball is traveling at 139 feet per second. So now what?
So now all we have to do is solve for how long it takes for the ball to get to the plane.
Okay, let's let algebra do its thing.
52.5 feet divided by 139 feet per second is 0.377 of a second, which we can round off to 38 hundredths of a second.
Wow, 38 hundredths of a second. That's not much time to make up your mind about anything.
For $1 million, what is the largest organ in the human body? Oh, sorry, time's up. Sorry, nice try. For $1 million, what is the largest organ in the human body? Oh, sorry, too late. Nice try. What is the largest organ in the human body?
The skin?
That's the right answer, but it took too long. Troy, you only have 38 hundredths of a second to decide whether or not to swing at the ball. That's insane.
Well, actually, we have a lot less time than that.
How's that?
Well, once I decide to swing, it takes me time to get the bat all the way around. And I've got to get that bat started way before the ball gets there.
Right. 38 hundredths is the total time of the ball, but that doesn't account for swing time. Well, how long does it take you to get the bat from your shoulder to over the plate?
Well, about this long.
We can figure out how long it takes Troy to swing at the ball by using video frames. Video records at 30 frames a second, so we can just count the number of frames it takes for the bat to come around. Okay, at 30 frames a second, each frame is 1/30th of a second. So 6 frames is 6/30ths of a second.
I thought you said you could do it with just a tape measure and a calculator.
I lied.
Troy, it takes you 6/30ths of a second to swing your bat around. So we have to subtract that from the 38 hundredths of a second it takes the ball to reach you at the plate.
Yeah, if you convert the 30ths into hundredths, it's going to be a lot easier.
Oh, okay, how do we do that?
Just divide 6 by 30, and you get 2/10 of a second. It's a lot easier to subtract that.
Okay, so I gotta subtract 0.2 from the 0.38, and we get, wow, 18 hundredths of a second for you to decide to swing at the pitch.
Yeah, that's not much time.
18 hundredths of a second with a 95 mile an hour pitch? Oh, and it gets lower than that with the faster pitches.
Yeah, I'm not sure I want to completely know about that.
18 hundredths of a second looks something like this. That's nuts, right? Who could decide anything that fast? Now for $1 million, Zoe. Who was the first president of the United States? Sorry, too late. I'm sorry. Nice try. Who was the first president of the United States? Oh, sorry. Who was the first president of the United States? Oh, sorry, too late. So it's no wonder hitting a baseball is one of the hardest things to do in all of sports. The batter only has 18 hundredths of a second to decide whether a pitch is high or low, inside or away. 18 hundredths of a second. And then after all that, he has to put the bat in the perfect position over the plate to hit the ball. That means getting 3 inches of bat to connect with 3.5 inches of ball. To give you some idea of how fast that is, that's it. That's all. The human brain is an amazing thing. Just think about all the information it can process in just 18 hundredths of a second. Oh, sorry, you're gonna need that.
So Troy, how do you guys ever do it? I mean, how do you ever hit a fastball?
Well, the first thing is you can't think about it. It becomes instinctive.
Right.
You know, we've done it so long. You know, like I've been playing since I was 5 years old, and it becomes something that's just reactionary. You don't think about it, because if you have a chance to think about it, you know, it's too late. The ball's by you.
What about the ball coming in? Can you tell anything from the way the ball's moving?
Absolutely. I mean, each pitch looks different based on what the seams are doing, the rotation of the ball. And that's what has to become habit, is just seeing and recognizing those so fast and so quick. Like you said, we only have 0.18 seconds to decide whether it's a ball, it's a strike. You know, if you want to swing, if you don't want to swing.
Are we there yet? Speed times time equals distance is a great thing to know. You can use it to figure out all kinds of things, like how much longer it's going to take you to get where you're going. How fast are we going? 55 miles per hour. How much further is it? 41 miles. So, 55 miles per hour, our speed, times time, gives us 41, our distance. So, to solve for time, we just divide 41 by 55 to get 74 1/100ths of an hour. How many minutes in 74 1/100ths of an hour? You know what? I'm gonna let you figure that one out. Okay, guys, so what did we learn?
For problems involving speed, distance, and time, you can use the equation speed times time equals distance.
You just have to solve for the variable.
And all the units of the equation have to agree to solve it, just like we did for miles per hour and feet.
We did this with the equation miles per hour times 5,280 divided by 3,600.
Play ball! Okay, we're testing Kristen's reaction time. You ready? Go. Ah. Okay, that's 0.19. Not bad. Listen, if you guys want to test your reaction time for your team or your class, you can check out how to do it on our website. Come to sportsfigures.espn.com. Well, that's it. We'd like to thank Troy Gloss and our students from Rialto High, Stephanie, Kirsten, Joseph, Shandara, Manny, and Logan, for helping us out here today on ESPN Sports Figures, The Math Reaction. Ooh, that's a good one.